This video is about the basics of trigonometry. What exactly are sines and cosines and tangents anyway? And where in the world do all of those formulas that you see here come from? Well, let's try to find out. Sometimes it's handy to figure out what some words mean, and the word trigonometry is pretty straightforward. Tri comes from the Latin for three, like triathlon. Gon from the Latin for angle, as in polygon, a figure with many angles. And metry means to measure something. And if you put that together, trigonometry doesn't quite sound right, so you stick another vowel in there to make the whole thing sound a little bit better, trigonometry. Even though we're going to be talking about triangles, we really need to start with a circle in order to understand them. And we also need a line. Now we can put this line anywhere we like. We could put it here, outside the circle. We could have it crossing into the interior of the circle. Or we could have it go in between and have it just touching the circle. That's going to be an important kind of line, and we call a line that's just touching the circle a tangent line, which comes from the Latin for touching. It's a line that's just touching the circle. We could put that tangent line anywhere we like. We could put it here, we could put it here, but we're going to put it here, like so. We're also going to need a horizontal reference line drawn from the center and extending to the right. And for the way we've made it, these two lines are going to be perpendicular to each other. Now we don't need all of those lines, so let's clean it up a bit. And we've gotten rid of one. Let's get rid of the other. So we're left with something that looks like this. Now we're going to construct the circle in such a way that it has a size, a radius of 1. 1 what? It doesn't really matter. 1 inch, 1 mile, 1 centimeter, 1 kilometer, 1 anything you want to think of. We're also going to put in another line because we need to have a line at some kind of an angle at the center of the circle. And there we go. We now have a triangle. We're going to refer to that angle using the Greek letter theta. And that line right there that you see in red, the length of that line that is tangent to the circle extending from the reference line to where it intersects our line at the angle theta, we call that length, by definition, the tangent of the angle theta for a unit circle. Now we need to be a little bit careful here. Oftentimes you're going to hear me say just the word tangent or write just the word tangent or tan, but it's important for you to remember that you only have trigonometric functions of angles. So if I really wanted to be precise, I should always say tangent of an angle. I should write tangent of theta or tan theta. That can get a little awkward and cluttered, having to always say or write the angle, so I'm going to be oftentimes just writing the word tangent or an abbreviation, TAN, or just sine or just cosine. But you should always remember that you take the tangent of an angle, the sine of an angle, the cosine of an angle, and so on. Okay, let's see what we have. We have a little triangle there. That line that we drew at the angle theta, that is cutting through the circle, that one right there, is called the secant. And it's called the secant because it comes from the Latin word for cutting. It's a line that cuts through the circle, as you see here. Here's another line, and that one is called the sine. Why sine? Well, that one's a little bit more complicated to explain, and in order to understand its origin, let's get rid of some of the extra lines here for a minute and just have that. Let's extend it down to the other side of the circle, and we don't need to call it sine anymore. Now, let's look at that little bit of arc right there, and let's get rid of the rest of the circle. Looking at that, you can imagine it being an archer's bow, with the red line being the bowstring. And let's come back to that and put it back where it belongs. In fact, that's where that word ultimately comes from. The word sine comes from the Sanskrit word for bowstring, and you can see that that's what that kind of looks like. Now we only wind up using half of that, but that's where that word comes from, and maybe that'll help you to remember. Let's put some of that back together. So we have our triangle there, we have sine in it, and let's put in the other trigonometric functions. We have tangent. the length of the line that is tangent to the circle from the reference line to where it intersects our line at theta. The secant line, the length of the line that cuts through the circle up until it intersects the tangent line. We have the sine in there, kind of half the length of that bowstring, and we're reminding you that this is a unit circle. All right, let's clean that up just a little bit. And I'm going to highlight our triangle. Again, unit circle, secant, sine, tangent. Now I need to emphasize that the unit circle extends from the center of the circle to the end over there. It's not just the length of the line from the center to where we have our sine line, it goes all the way to the tangent line. Again, to be correct here, I should really say that the length of that line is the secant of theta. The length of that line is the sine of theta. The length of that line is the tangent of theta for a unit circle. That gets a little messy. It clutters up the diagram, so we remove those thetas, but you should understand that those are implied here. All right, let's look at this one triangle and see what we can do with it. What we have here is a right triangle, and we know all the sides, so we should be able to figure out a relationship between those sides. And if you use the Pythagorean theorem, a squared plus b squared equals c squared, then you should be able to see that the tangent squared plus 1 squared equals secant squared. Or, since 1 squared is just 1, tan squared plus 1 equals secant squared. This is one of those identities that if you haven't seen it, you will, or perhaps you've seen it already but just hadn't been shown how it comes about. All right, let's go back to our triangle here. I've gotten rid of most of the labels. I'm going to put in this time a vertical reference line. And that angle in there that you see in red is the complementary angle, or the complement of theta. That means that that angle plus theta equals 90 degrees. Complementary is the angle you need to add to another angle to equal 90 degrees. I'm going to call it just cotheta. Now let's do with cotheta what we did with theta. We have a line tangent to the circle coming from our reference line up to where it meets the line that cuts through the circle at our reference angle cotheta. Let's get rid of a little bit of the clutter. Remember that this is a unit circle. The length of that red line, the line that is tangent to the circle, is the tangent of the co-angle, or the tangent of cotheta. And we call the tangent of cotheta the cotangent of theta. So the tangent of the complement of theta is the complementary tangent of theta. We can either call that line the tangent of cotheta, or we can call it the cotangent of theta. They mean exactly the same thing, but the standard is to call it the cotangent of theta. Okay, here we have the secant of cotheta, and that's called the cosecant of theta. So the secant of the complement of theta is the complementary secant, or cosecant, of theta. So, one more time. We can call the length of that line either the secant of cotheta or the cosecant of theta, but the standard is to call it the cosecant of theta. And we can call that line the sine of the complement of theta, or we can call it the complementary sine, or cosine, of theta. So, there's theta again, and we have the sine of the complement of theta, or the cosine of theta. Either way, sine of cotheta or cosine of theta, but the standard is to call it the cosine of theta. So let's put all of that together now. On this triangle, based on a unit circle, we have the complement of theta, or cotheta. We have the length of the tangent line for cotheta, or the cotangent of theta. We have a line that cuts through the circle, the secant line for cotheta, or the cosecant of theta. We have the length of the half of a bowstring, the sine of cotheta, or the cosine of theta. So, we have the cotangent of theta, the cosine of theta, and the cosecant of theta. Let's put this triangle together with the one we had earlier, side by side, and let's do something with them. I'm changing color just so we can better keep track as we move them together, and bear in mind that the length of that secant line that you see there extends from the center of the circle up to that tangent line, and that the cosecant line over there on the right extends from the center of the circle to the cotangent line that you see there. All right, let's bring them together and let's see what we can do. We'll enlarge them a little bit. So this is it. All of the basics of trigonometry are within these two triangles. The red triangle made up with the angle theta, and the complementary triangle made up with the complement of theta, or cotheta. That's a little cluttered, so let's go ahead and put in abbreviations for all of these things. And we're going to be concerned with this triangle right here. Let's change the color back to red in order to make things stand out just a little bit more. And let's get rid of a few of these extra lines so we can focus our attention on just one of these things here. We're going to go back and include theta, and we had sine before. If the length of that red line there is cosine, then that means that red line I'm showing there on the bottom is cosine as well. Let's get rid of some of the extra things that we don't need right now. This is the triangle that we're going to work with. The hypotenuse is 1, one of the sides is cosine and the other is sine, and it's a right angle triangle. Let's make it stand out just a little bit more. If we apply the Pythagorean theorem to this triangle, we get sine squared plus cosine squared equals 1 squared. Well, 1 squared is just 1. So here's another identity that comes straight out of these triangles. Sine squared plus cosine squared equals 1. All right, let's go back to what we had earlier. There are two triangles there, an inner one and an outer one. I'm moving the inner one to the right and highlighting each of them. Both of these triangles have the angle theta, and they both have right angles. That means that they are similar triangles. And that means that the ratio of the sides on one of those triangles will equal the ratio of the sides, corresponding sides, on the other triangle. So, for each triangle, we're going to look at the ratio of the hypotenuse divided by the adjacent side. For the triangle on the left, the hypotenuse is secant and the adjacent side is 1. For the triangle on the right, the hypotenuse is 1 and the adjacent side is cosine. So that gives us secant divided by 1 equals 1 divided by cosine. And we can simplify that to just secant is 1 over cosine. Now don't think of secant as being defined as 1 over cosine. Think of secant equaling 1 over cosine as a consequence of the definitions that we have, namely that the secant is the length of the line cutting through a circle, that the cosine is the length of half a bowstring for the coangle, and so on for a unit circle. All right, let's do that again, but with the sides opposite and adjacent this time. For the triangle on the left, the opposite side is the tangent, and the adjacent side is 1. For the triangle on the right, the opposite side is sine, and the adjacent side is cosine. So we have tangent over 1 is equal to sine over cosine. Well, tangent divided by 1 is just tangent, and so that simplifies to tangent equals sine divided by cosine. Again, don't think of tangent being defined as sine over cosine. Tangent is defined as the length of the tangent on a unit circle. This formula is merely a consequence of that and the other definitions. Let's look at the identities that we found so far. Tangent squared plus 1 equals secant squared. Sine squared plus cosine squared equals 1. Secant equals 1 over cosine, and tangent is sine divided by cosine. All of those are the consequences of the way we've defined things. Now what I'd like you to do is find a few identities on your own. So, for example, we came up with tangent squared plus 1 equals secant squared. go back and look at the triangle that has the cotangent and the cosecant. See if you can work out from that the cotangent squared plus 1 is equal to the cosecant squared. Then find the appropriate triangles, and just like we came up with secant equals 1 over cosine, see if you can derive the identity that cosecant equals 1 over sine. And finally, just like we had tangent equals sine over cosine, see if you can work out that cotangent equals cosine over sine. All right, there we go. In summary then, the most basic aspects of trigonometry can be seen by the definitions set up in these triangles. A set of triangles that work with theta, giving us the length of the line that is tangent to the circle, half a bowstring, the sine, and a line that cuts through the circle, the secant. Plus, we can look at the triangles for the corresponding complementary angle, and that gives us the complementary tangent or cotangent, the complementary sine or cosine, and the complementary secant or cosecant. And once we have those definitions, we can get at most of the identities that you'll study by just applying the Pythagorean theorem or using similar triangles. And that's it. I hope this has helped you, and good luck with your studies of trigonometry.